So this video we are going to learn about functions. So your objectives is that you can identify a function by its graph and table, and then you can find the range of a function with a given domain. So in functions, you can look at the graph to decide whether something is called a function. To do that, we do something called the vertical line test, which all the vertical line test is drawing a whole bunch of vertical lines on the graph. So here, I'm just going to draw vertical lines. Notice the left side, I labeled them as functions. And then this side, the right side, I label them not as functions. So what's the difference? How can you tell between a function and a non-function? Well, if you look on the function side, every vertical line, and I could draw very many more, only touches the graph one time. Where on this side, at some point, it touches, and one vertical line touches twice. So here, like these ones are okay, but right here, it touches those 2 points. And then here, it fails right here. So it has to pass the vertical line test, and it only can touch one time. If there's any vertical line you can draw and touches twice, you can't. Now some students might say, well, right here, but this actually keeps going in and in more and more on both sides. So from a table. So if I want to complete a table of a function, I can just pick points. So we're going to just select points on the graph. Do about 4 of them in each one. I have 0, 2, 1, 1, 2, 0, 3, 1. So here I can pick points. I'm going to do about 3 of them on this one. So I have 0, 1, 1, 2, and then I have 4, 3. So on this one I don't have very many to pick from. I think I only have 4 I can do that are nice points. These 4. So I have the point, -3, 0, and then on the other side I have 3, 0. Then I have 0, 1, and 0, -1. So on this one, these are all a bunch of points, so I can go -2, 1, -1, 0, 0, -1, 0, -2, and I can keep going 1, 1. So what's the difference? So in these tables, notice there's only one x value. But on this side, we have to double up on the x values. So for something to be a function, every x can only go to one y value. Okay. Otherwise, we get points that stack, like here, which makes it fail the vertical line test. So over here, we have 0 goes to 1 and 0 goes to -1. We do not want that. Now, we can have 2 different x's go to the same y value, which is right here, because we have this point and this point. That is okay. But again, we can't have 2 x values go to different y's, because then we're going to get points like this, which stack on top of each other, which makes it fail the vertical line test. So what is a function? A function is where every input x, where there is only one output y. So if you think you have x's here, if I have 0, 1, 2, 3, these are x values. They only can go to one y value. So if I have -3, 2, 5, so if I plug in 0, I get 2. If I plug in 1, I get -3. But also when I plug in 2, I get -3. That's okay. And then here, 3, I get 5. 2 different x values can go to the same y value, but I can't have a double arrow from 1 going down to 5. So to make this not a function, so this is not a function, 1 also goes to 5. That means it's not a function. Right here is an analogy I use. If you think of a vending machine, if you were the owner of this vending machine and it didn't work properly, means if you would plug in a code, so say you plug in A4, you type in A4 into the code, and what came out, if it was working properly, say you got a Snickers. Right? The owner of this vending machine would be very happy about this. He would not be very happy if I type in A4 and you got a Snickers out, but then you also got M&Ms. That means it is not functioning properly. So here, this is your input, and you get 1 output. So that means it is a function. Where here, A4 is your input, but you got 2 outputs, which means it's not functioning properly. So in functions, we use function notation like f of x, g of x, h of s, and so on. We can use any letter. And when we know an equation is a function, we use this notation. So f of x equals 2x plus 7 and g of x equals x squared plus 10. These are both functions. The x in the f of x is the input value. So if I have f of 2, means we're inputting 2 in for x, which would be very important. So if I have f of 6, that means I'm going to plug 6 in for x and figure what it equals, which in this case, 2 times 6 is 12 plus 17 is 19. So in functions, every function has a domain and every function has a range. And the way to think of it is that a domain are all the possible inputs of the function. This is what you're putting into the function. Where the range is your output. What are you getting out? So if you think of the candy bar or the vending machine analogy, A4 was your input and then your output was the Snickers. If you would type in another one like B3, that's output may have been the M&Ms. Here I put little glimpse of the Lion King. I like to think of domain like the lion. The lion are in charge, so they are in charge of what goes in. And then the lion's in charge of what? They're in charge of their land, their domain. Okay, this is their range in that thing. This is what they own. King of the jungle and so forth. So here, give the range with the given domain. So in my domain, my input is 0, 4, and 5. So I need to find what my output would be. So I need to plug in values for x. So I'm going to find f of 0. I need to find f of 4. And I need to find f of 5. So I'm just going to replace the x. So I have 3 times 0 plus 1. 3 times 0 is 0. Plus 1 is 1. So 1 is in my range. Here I'm going to 3 times 4 plus 1. That's 12 plus 1, which is 13. And then I have 3 times 5 plus 1. That is 15 plus 1. That is 16. So in my range, I have 1, 13, and 16. So when you're writing your range, you do need these brackets. These are called set brackets because it's a set. The domain is in the set, the range is in the set. And you also want to put them in order from least to greatest, which in this case our answers turned out to be from least to greatest. One more example. This might be a good time to pause the video and try to do this on your own and then check answers with me if you got the previous slide. So I'm finding f of negative 2 because that is in my domain. So I have 5 times negative 2 minus 4 plus 1. Then I need to find f of 4. So I have 5 times 4 minus 4 plus 1. And then we need to find f of 10. So I replace my x, or substitute in for x. So I get 10 minus 4 plus 1. So simplifying this down, 2 times 4, that's negative 6. Negative 6 times 5 is negative 30 plus 1. Negative 29 is in my range. 4 minus 4 is 0. 0 times 5 is 0. Plus 1 is 1. 10 minus 4 is 6. 6 times 5 is 30. Plus 1 is 31. Alright, so in my range, in numerical order, negative 29 is the smallest. Then it's 1, and then it's 31. Again, I need my set brackets to show it's a set, and then they need to be in numerical order. So that concludes this video. Just kind of review, functions need to pass the vertical line test. So it only can touch one time for it to be a function. In the table, the x values only have one unique y value. You can't have two x's go to the same one. So we can have 2 go to 1 and 2 go to like 3. That would not be a function. The domain is your input. The range is your output. And in the table, oh, this actually says the same thing, so we don't even need that one. All right, so those are your 3 things you kind of need to remember. All right, and again, one last reminder to do your reflection so you get credit for watching this video.